Hello, I'm Dr. Robin Green. I'm a lecturer in psychology in the University of Leicester, and today I'm going to be giving you a short presentation about how we solve problems and the psychological theories behind how we define problems, but also how people try and solve them. So in this little taster mini lecture, I'm going to talk about sort of three broad areas. So one is just defining what actually constitutes a problem, and then some psychological explanations for how we solve problems, and some additional factors involved in the solving of problems. So what is a problem? A problem is something where there is a clear goal required. So there is a clear objective, well, not necessarily clear in terms of how it's defined, but there's a target which needs to be reached. There has to be a purpose for it. And it involves engaging in multiple controlled processes. So not sort of random actions, but detailed planning and checking and monitoring. And an important aspect of what a problem is that the solution is not immediate due to lack of instantly accessible relevant knowledge. So it's something where you need to actually do multiple actions and to obtain the goal. So we can define problems in multiple ways. So if you can think of it like an axis, there are two dimensions. So one is about how well defined a problem is. So well-defined problems are all aspects of the problem are clearly specified. That means you know all the rules. So the initial state, so what the problem looks like at the beginning, and you know what the desired outcome is from the very beginning. You don't have to figure that out. That's given to you. Any ranges of possible moves or strategies, actions are already defined. So like in our example here, we have a chessboard where the starting state is already given to you, and the objective, which is to have a checkmate, is clearly defined. And you are told that each piece has a very set amount of moves, and you can only move in certain ways in a turn-taking fashion. Also, the important aspect of well-defined problems is that there are optimal strategies. So that you can say there's a mathematical or logistical perfect way of doing it, or a very efficient way of doing it. And most of the research in psychology that looks into problem solving mainly engaged in well-defined problems because they're easy to control, easy to manipulate. You know what sort of moves you can limit people to, so you can investigate various other actions or psychological processes from there. However, a lot of everyday life problems arise and they're not necessarily well-defined, or they're called ill-defined. That is, the problem or task is underspecified. So you might come into a situation, like say you want to look for a job. Now the nature of that job, when you have to do it, the exact way you do it can vary. The time it takes, it varies. Different strategies as to how you fill in an application form or write a CV or present in an interview, or types of selection processes will vary. There's no clear single strategy to achieve the outcome either. So people can achieve the problem versus in various ways. The outcome or goal is vague. You have to define it yourself, and you have to define what that means. So, for example, looking for a job, or finding a romantic partner, or raising children, there are no clear, concrete and objective criteria in order to solve this, or to fulfill these functions. You have to find the answer your own way. Or let's say you got locked out of your house. You might know the desired outcome is to go back in your house, but how you do it may come in various ways. Now, on another dimension, another axis, is how much knowledge is required to solve the problem. So, knowledge lean problems, which you'll find are quite commonly used in psychology experiments, but also in things like escape rooms, where you don't have to be an expert in an escape room. It does, because you don't need to have a very specific knowledge or training. And all the information you need to do to solve the problem is contained in what's known as the initial problem statement. That is, what is the situation? And you use your already natural resources and skills that you've already got in order to solve the problem. A knowledge-rich problem, however, is the opposite, where you need very specific information to solve the problem. So, for example, if, let's say, your car breaks down, you need to have a certain knowledge of how to fix cars in order for you to solve it. So if you lack that knowledge, you are stuck. It's not something that you can just use sort of initiative to always necessarily solve. You need to have a very specific and detailed training to solve some problems. There has been defined like a problem-solving cycle, which tries to generalize how we solve problems. So first of all, you have to identify what the problem is, and then define the nature of that problem. What is it? What is the goal that needs to be achieved? What are the materials or the available resources you've got around you? What can and can't you do in a certain situation? Like, for example, being locked in an escape room and you have to get out in 60 minutes. What items have you got in your immediate vicinity? Then you have to construct a strategy for problem solving, so having to plan and then organize information about the problem. And then having to allocate resources. So that means allocation of effort, but also of attention, and also deciding like what task you want to do first in order to solve the problem. And then while you're doing these range of actions, you want to monitor how they're going to see, is it making you closer to solving the problem? Seeing what the outcomes of each of your actions are to see what the consequences are. And then you evaluate what's been done so that you assess, does the is the problem solved in a way, or has it been has the problem changed? Has the goal been achieved, or are you closer to the goal, etc.? And then you carry on with the rest of the cycle. There are various explanations as to how you go about doing this. So you had one which was the cycle of general sort of problem solving, but also some very classic explanations are simply cases of trial and error. So that's basically sort of trying out random different activities until you stumble upon the correct solution. So one classic example is by Thorndike in 1897, where he put a cat in a box contraption where in order to get out you had to press a pedal, and the cat doesn't know that they had to press the lever, so he just sort of does various random things until just accidentally stumbling upon the pedal. And then the door releases and escapes from the puzzle box. And then what Thorndike would do with the cat is to try and then put the cat back in the box and see whether the cat would remember doing this. And it takes quite a while for the cat to learn, if I press the pedal, I would escape from the puzzle box. Now, this is something that occurs in everyday life. It's particularly like things with computer problems, with the simple like turning it off and turning it on again, or pressing Control-Alt-Delete might solve some of your problems. But it's very effortful, it's quite tedious, it's quite reactionary, and it's generally a slow process which really is based on persistence. There's not really any planning involved. And we know that not all problems involve just simply reacting to things. You have to sort of use past history or past knowledge and sort of stopping and thinking and strategizing about the problem. People do get stuck in problems, and particularly doing these sort of persistent and really sort of repetitive actions. And so one explanation as to why people might get stuck, particularly in sort of more obscure problems where you have to reimagine how objects are used and you have to be creative in your solving of problems, is by the case of functional fixedness. And that is the mistaken assumption that any given object in a problem possesses only a limited number of uses. And this is by a psychologist called Duncker in 1945, where he asked participants to attach a candle to a wall using a candle, some sort of tacks in a cardboard box, and some matches. And people got stuck in this problem because they kind of thought only the box was used for containing the tacks and not necessarily used as some sort of like ledge, or that the tacks can be used to attach to the wick or attach the box in this case. So people get stuck because they think only the objects given are for the use that they normally would have. And McCarthy in 2012 elaborated on this and said that there's aspects of objects which are essential for problem solving are ignored in favor of typical used and their composition. And you can actually solve more problems if you are explicitly thinking to yourself or being even told that if you see the objects as function free, so that is, they are used in more ways, you can use these in various different ways, then people are more likely to be more creative in their problem solving and not fall into this functional fixedness trap. Another way that people get stuck is by something called mental set. So this is basically your sort of past history, your set of problem solving strategies that you've used before, and you just sort of take them from your past experience and then just apply them to the current problem you're engaged with. But it doesn't always work, and it's people persisting, keep using it because it worked before, but doesn't necessarily mean it's work. Now, using this sort of mental set generally helps in most situations because it requires you to plan less. You've got something which is stored in your memory banks, and you can then apply it to some other problems. So that reduces something called processing demand. So that means thinking time. But the only problem is if you over-apply it to problems which are not appropriate or doesn't require that, you end up in a state of impasse or something, or being stuck. So later on in the 1970s, there was a move away from this sort of trial and error or this sort of fixed approach, and tried to use sort of computer metaphors to describe how we solve problems. One example, which I'm going to describe in a bit, is something called problem space identification. Another place is used in heuristics. So heuristics are basically like sort of rules of thumb or like little sort of cognitive shortcuts. So from past experiences, and sort of quick, sort of very easy to access rules that you've used before to help solve a problem. Hill climbing, which is the idea of basically graduating different aspects of the task into smaller sub-tasks, so that you climb up a big hill in smaller steps, so that you have smaller goal points that will slowly but surely lead you to the top of the hill, thus achieving your goal. And progress monitoring. That means that you actively process the information around you and then evaluate it to how close you are to achieving your goal. Newell and Simon in 1972 argued that how you represent problems, particularly in something like the Towers of Hanoi, where you have to move different rings from one pole to another. You mentally represent that. You basically draw a mental plan, a mental schematic of all the possible outcomes in your mind, and then you draw it like a flowchart, like this example here, in order for you to solve the problem, saying, okay, here's what it looks like now. What would it look like if I did this? Before actually doing it. So you could argue this is basically mental strategizing. So this is the idea that you mentally represent in your mind all the possible combinations in a very structured and hierarchical way, and coming up with a clear strategy. And then you evaluate and then come up with another mental set once you've achieved one action. Then you mentally represent. So what this information processing approach argues is that you actively process information. You're not just a passive responder. You actually deliberate over different pieces of information. And so in this case of the Tower of London or the Tower of Hanoi, where you have to move certain discs from one pole to another, they ask participants to just plan. Don't necessarily touch anything, but just actually plan out how your moves are going to go without physically doing it. And with the Towers of Hanoi or Towers of London, there is an optimal sort of mathematical sort of move set, and those who took longer in the pre-planning stage actually were more efficient and actually solved the puzzle without having to make a lot of regress errors or many mistakes. And also, this applied to solving the Rubik's cube. So people, if you ask people to mentally manipulate and plan and use sort of algorithm, once they've learned the algorithm, they can solve the Rubik's cube easily. Another explanation for why people solve problems is more from the basis of insight. So the idea that you get so stuck on a problem that you give up, but somehow there's a light bulb moment, that aha, the sudden lightning bolt of inspiration comes when you weren't expecting it. So Poincare in 1913 argued that insight is basically something that's sudden, it's abrupt, it's not when you're consciously thinking about it, it's when you're least expecting it. And once you have that sudden realization of this is what the problem is and this is how to solve it, it makes things a lot easier. It gives you an increase in something called positive affect, which means that you feel happy and you feel a lot more confident about yourself. And one argument is that sometimes being overly in your head and overly planning for too much actually creates a lot of barriers and stress. So sometimes just sort of leaving it a bit and letting your unconscious mind process the information, it reconfigures the information, moving it around to reconfigure to a whole new representation. So that means you see the problem in a very different way, and thus when the answer surfaces to your conscious mind, that is called insight from a big height. So in this summary, problems can come in various forms. Particularly, you can define them as whether you require lots of knowledge or use your already existing knowledge, whether the outcome and the goal is very well defined or not so well defined. And people have tried to explain it via different ways. So the sort of behaviorist approach said that you just do things by lots of actions, by trial and error, and persistent, but it's slow and tedious. Information processing accounts suggest that we represent different scenarios using a sort of mental set and using rules of thumb or previous knowledge and planning. People get stuck because they might see objects and relationship with objects in a very sort of stereotyped way, and actually being free from that actually releases your ability to solve problems, as well as your sort of mental set. So just using your sort of past mental library of different solutions sometimes can be helpful, but sometimes can hinder you. And insight being the sort of final explanation of how you can, when people get stuck in the problem, people can step away from it for a little while and then come back and see the problem with fresh eyes, if you like, as the unconscious reconfiguration of the problem is occurring, and then a solution comes suddenly. Thank you very much for listening to this short mini lecture, and I hope that you can try and apply these different things when you're having to solve problems in the future. Thank you very much.